Hey YouTube, welcome back. Today's I guess it's ninth part of our series of system design fundamentals. If you don't see any video of this series, I just suggest that you just look at the videos before, so you'll understand what we have designed, because we were building all of this system in the last 7 episodes. But anyway, I will make a small recap so you understand what we have built. So basically, right now we were building a scalable system design for this. Now we have a client. This client wanna connect with the actual web tier. So basically, the client who requires the load balancer IP address from a domain name system. It's in the domain, and the domain system will return the IP address. Once the client get the IP address, the client will send an HTTP request to the load balancer, and the load balancer will distribute all the incoming requests from multiple clients to our web tier. We have multiple web servers are working at the same time, because it's more scalable to scale out instead of scale up. Because if we just had one web server and we just add RAM and CPU to it, this will put us into two problems. One, we have a single point of failure. Second, it's quite limited. We can't add RAM until the end. So it's a good practice to scale everything out and just add multiple web server, and the load balancer will handle the incoming request and distribute the request for all of the web servers. So we'll make sure that there is no web server has overload, or there is no web server has no request at all. And if one of our web servers went down, the load balancer will know that, and will just redirect all the other requests to this web server request to the other two web servers. And into the data type, basically we have master slave architecture. Basically, the master works handle the write operations, the slave handle the read operations. When the master is updated, it takes a copy and save it on the slaves, to the slaves. Basically, if one of the slaves went down, the other one will continue working. If the master went down, one of the slaves will promote it as a master, and basically, we have two slaves that supports the read operation. This will make the read operation way more easier, way more faster. And this architecture, it's improve the scalability, improve the availability, and also improves the reliability of the actual data. To improve the latency and the time response, we created a cache system, a cache storage. And a cache is the memory storage. Basically, when the web tier get a specific request, instead of accessing the data tier directly, it will access the cache first. If the cache, because of cache, it's in memory storage, so it's way more faster. If the cache has the data, it will send it back directly to the web tier. If the cache doesn't have the data, the web tier will access the web server will request the data from the database and store it in the cache. And also to improve the latency of the images, the CSS, the HTML, all of the certain content, we use a content delivery network, a CDN, basically. And basically, if you have an image and we store this image, maybe in we would require it from a blob storage or something like that, and this blob storage, like, it's 10 kilo away. And instead of each time accessing it from geographic position, the CDN, it's basically a server that it's a close to the client. So instead of just request the image from a CDN that lives 100 kilometer away, it will just access it from the CDN directly, and it's maybe 5 kilometer away. And this improves the latency and make the user experience way more better. And we talked the last episode that we talked about the stateless web tier. Basically, we don't want to have our web server quite stateful. So no, each web server will store no state at all. So basically, it will make our request more reliable. It will make our request more scalable. And instead of each web server has its own state, because this will put a problem if one of the server went down. The client will not be the client that used to access this web server will not be able to access the others, because it doesn't have, the other doesn't has its data, its session data basically. So and if maybe if it doesn't, if maybe the other thing that if one of the, if the client just the load balancer just routed it to a wrong web server also, we could have the same issue. So basically we had a share state, but by solving this problem we said that we will go to a stateful architecture. And the stateful architecture, that means that stateless, stateless architecture. And basically stateless, that means the web tier doesn't store any state at all. The web tier will require maybe the state from the client. Maybe the client have the store the actual token or something like that, or the web tier basically has like a shared database. For example, we choose NoSQL for because it's easy to scale and easy to remove and add. Maybe you can use a cache system, a Redis storage, and or you can use a SQL. It's like we would choose to use NoSQL because it's pretty easy to scale out, and yeah, it's a pretty easy to scale and it's easy to remove and add to it. So basically, instead of each web server had its own state, right now we have only we have a shared state. And basically, let's say that congratulations, basically our website right now it grows rapidly and attracts a lot of users to use it basically, and we have a lot of users globally, and we have right now global users, and if we want to improve the actual availability and providing the better user experience across the geographical areas, basically we should create what is called a data center. Basically what a data center, basically it's a multi-region data center. Basically the multi-region data center architecture, it's a design pattern actually used in system design that involves deploying infrastructure and services across multiple geographic geographic regions. This approach basically is used to improve the availability, also the reliability and the performance of the system, because we only requesting the data from the closest geographical position of the actual user. Because we are distributing the workloads across multiple regions and minimizing the impact of the outage basically. And in the multi-region architecture, basically the data centers are typically deployed in different geographic regions around the world, and are connected by high-speed networks and interconnects. Basically, each data center may contain a subset of the system infrastructure and services, and may be designed to handle specific subset of traffic workloads, for example. And the good thing about that, basically, we are improve the availability by deploying infrastructure and services across multiple regions. The system can continue to operate even if one or more regions experience outages or distributions. Improve reliability by improve reliability by distributing workloads across multiple regions. The system can reduce the risk of single points of failure, and improve overall reliability. Improve performance by deploying infrastructure and services closer to end users. The system can reduce the latency and improve performance. And the last thing is that we improve disaster recovery by replicating data and infrastructure across multiple regions. The system can provide better disaster recovery capabilities, and it can be quickly recovered from region outages. And basically this is it sounds pretty good, but let's just talk about how it looks like and how we will handle it. So we have this this one, and we will all of this WebT with data center and these things. And so basically what we're going to do is that first let's create one here, and let's make it no, let's make it on. Okay, and can we yeah, okay, can we take all of that and just try to take that. And okay, it doesn't work as I expected, but let's just try to make it work. And delete this and delete this, and Mm-hmm. And yeah. So for this example, we have this one. No, no, go back. Okay, can we take all of that? Yeah. Okay, okay. And let's just take it like that. And put this here, and put this here. And maybe like okay, and let's copy this one. No, copy it all. Okay, so let's just put this one here, and let's add text. So basically, let's say this one, it will be let's say the EU 1, for example, and maybe this is the first one that serves the maybe you have two data centers for the EU, and let's put this one EU2, and yeah, maybe these data centers also serve the EU. Yeah, just can you make this thickness quite bigger? Mm-hmm. Mm-hmm. And let's just add yep. Okay, so okay, let's just talk about what we have did here. So basically in this setup that we have built here, we have two data centers, like basically and basically the users are routed to a specific one of these things, one of these data centers based on geographic. So basically we'll use geographic DNS, and basically the geographic domain system will make sure that we are routing to the specific right data centers basically. And basically in the good thing about this architecture, basically in the event of any significant data center outage, if you have any problem with like let's say that this center went down, the thing that we directly basically traffic all of the if this one doesn't work anymore, we basically direct all of the traffic to this one directly, and to any healthy the healthy data center. So we make sure that we are maximizing our availability. And also if maybe we have the traffic direction maybe effect tools that because are needed to direct traffic to the correct data center basically, because like if you have the GNS, this can use to basically direct the traffic to the nearest data center. So basically this is the technique that we have to use to make sure that we are sending our own request to the nearest data centers to make sure that we are maximizing the user experience. And we have if we have data outages basically, and we are connecting to the new data, the problem that we could found that users from different regions could like use different local databases or caches basically. So basically in the failover, the traffic might be routed to the data centers that doesn't has this specific data. So basically a good solution to this one is to replicate all the data across the multiple data centers to make sure that we has the right data all the time. And yeah, that's it basically. And yeah, that's it basically. And And that's it for today's video. And I guess in the next video we will talk about the message queue, and maybe if we were quite lucky we could talk about the logging and metrics. I don't know if we have a time for that, but I guess we will talk in the next video about the message queue. And in this video we're done here. If you like my description, make sure to subscribe and hit the notification bell so you will never miss a video.